times t equals to 85 to 0.18 times t, where t is a measure in years. The first question is, what is the initial population when 0 years have passed? You need to use the formula, so you need to put 0 into t. And here you need to multiply this, and this is 0, so and here you eliminate these two. So it's 85.
As my partner Karen had says, we need to solve the problem, which is how many frogs will be after 2 years. So what we need to do, we need to substitute the t number, because it's the times, by 2, and after by 3, and after by 5. So first, the first step is substitute the 2 by the t. The 2 by the t. So after we have do that, we need to do this multiplication with each point 18 by 2. And the result will be 0.32. And after that, we need to solve this equation, who will be a result of 129.83, which means that we can have this number of frogs. So we do the like that, and it will be like 122 frogs. The second step is find with the number 3. So we do the same thing, we substitute, and 3, and here 3 too. So n3, it's equal to 18 by 3, which is 85 e to 0.54, which gave us a total of 145.86, which is like 146 frogs. This is the result for 3 years. And for the third step, what we need to do, we need to solve the problem with 5 years later. So what we do, we substitute to the number t, which means put a 5 here and a 5 here. So it means like 85 e up to 0.18 by 5, which gave us a total of 40, like is 0.4. After that, we multiply this operation, which gave us a total of 2009.06. We rounded is just 2009 frogs. This is for the 5 years later.
Well, the question C asks for the Graph-Del model given leaving t as a variable. Well, first, when we had 0 years, we had 85 frogs. Later, when we had 2 years, we had 122 frogs. When the time passed, in 3 years we had 146 frogs, and later when we have 5 years we have 290 frogs. Well, the graph will be like this. We have an intersection we have a y-intercept in 85 because it is when the population of frogs start to grow up.
We have to graph a new model from the same equation, but now with a growth rate of 40%. So the original formula is this one, the n times t equals 85 e raised to the power of 0.18 t, and now it should be like this, n times t 85 e raised to the power of 0.40. We change this number to the 40. This one. And it goes like this.
Well, based on the two graphs, answer the following. The question E asks for which equation from C or D depicts the model where the population grows faster. In the model D, that is this, the population grows faster because of the graph increases 85 faster.
Therefore, the final answer is that we have to replace the variables that are elapsed years. That means the T letter. So to get the answer, that will be the population of the frogs. For example, in the first one, we have to get the frogs population in the initial moment when we have passed 0 years. So we replace the 0 in the T. That we will get 85. So the initial population of frogs is 85. The same process is applied in both exercises with 2 and 3 years. Finally, we can conclude that this problem we can apply in the daily life because this formula is used sometimes in many different things, like the studies of the population in the countries, and they apply a similar process.